Today we'll talk about Mohr circle. So we already know how to calculate new stresses when a stress element is rotated at a particular angle, and we have to use transformation equations for that purpose. And we also can directly calculate where we will get the maximum normal stresses, which are also called the principal stresses, and we also have equations for that. We can also calculate the angle of maximum normal stresses, which is called principal angle. We also have equation for that. We can also calculate the maximum shear stresses, and we can also calculate the angle where we'll get the maximum shear stresses. So we have the equations to do everything we need, but there is another way to calculate or determine everything, which is called Mohr circle. So Mohr circle is another way where we can just draw all those stresses on a circle, and then we can visualize anything. So instead of using equations, we can just use this Mohr circle, and that would help us to visualize all possible stresses. So we can just directly see, and we can just determine on the graph on a circle that what would be the stresses at a particular angle, and we can also visualize the maximum stresses and maximum shear stresses and normal stresses. So this is overall procedure to draw the Mohr circle. So you have 7 steps basically, and we're gonna draw the Mohr circle today. So we're gonna follow these 7 steps. Step one is draw coordinate axis. So we're gonna draw x-axis, y-axis. When we'll do, it's gonna be much clearer, but I'm just gonna go through roughly like these steps. So first step is draw coordinate axis. We're gonna draw x and y axis. Then we'll calculate the center of that circle because we are trying to calculate the circle. So we have an equation of a circle. We'll calculate center of a circle. We'll calculate the radius of a circle. And once we'll have the center, we'll have the radius, we can just practically draw the circle. And then we'll look at our stress element, and our stress element has normal stresses and shear stresses. So we're gonna transform these normal stresses and shear stresses as a coordinate of that circle, and we're gonna draw those coordinate on a circle. And then we can also calculate angles, we can also calculate maximum stresses, and we're gonna see how we'll calculate. And we can also verify this by using these equations. So these are the 7 steps to draw Mohr circle. So just a quick review. So we have transformation equations, right? So whenever we have a stress element, we can use. So this is a stress element which is not rotated. It's like normal stress element. So if we want to calculate those new stresses, transform stresses at a particular angle, we can use these transformation equations to calculate the updated stresses, right? We also want to know at which particular angle we'll get the maximum normal stresses, which are called the principal stresses. We can calculate these maximum normal stresses and the angle which this stress element will be making at those normal maximum stresses, we can calculate using principal stresses equation, and we can also calculate the angle using principal angle. We can also figure out another angle where you will get the maximum shear stresses, and that angle is called the maximum shear angle. You can calculate by using this formula, and you can also calculate the maximum shear stresses by using this equations. So there are a lot of equations which we can use to calculate all the things which we need, but we can also use a Mohr circle to draw these stresses and directly visualize all these instead of using equations. So this is the 7 step procedure. Maybe you can open the workbook and you can like directly go there. This is the 7 steps we're gonna follow to draw a Mohr circle, and Mohr circle is gonna give us exactly all the information which we have been doing by using these equations like transformation equations and the principal stresses equations and maximum shear stress equation. So we're gonna uh, do example 10.3, and this example is basically the same example which we have been doing in example 10.1 and 10.2. So it's the basically same stress element. In example 10.1, we used this stress element, and in example 10.1, we asked like if this stress element is rotated 15 degrees, then what would be the transformed stresses? And we calculated those stresses by using transformation equations. In example 10.2, it was the same stress element, and the question was like calculate maximum normal stresses and the angle it would be making, and calculate the maximum shear stresses and the angle it would be making. And we used new set of equations, which were equations to calculate the maximum stresses, normal stresses, and the maximum shear stresses and the angles. and we did that. So now we have some of the results from example 10.1 and example 10.2. Now we're gonna draw the Mohr circle, and we can also verify all the answers, and we're gonna see how we can use uh, a circle to figure out all the stresses. So I'm gonna just write down what we had from the last time. So this is our stress element, right? This our stress element is untransformed stress element is so this is our element. We have stress X as 100 psi, and we had stress Y as negative 250 psi, and we had a shear stresses, and the shear stresses were 100 psi, right? So we can just write down these stresses. So our stress X is 100 psi, and our stress Y is negative 250 psi, and our tau xy is negative 100 psi because it's making a clockwise rotation of the axis. So uh, we also calculated the maximum stresses, right? So we know if we rotate the angle, we already know from example 10.2 that if we rotate the angle, our principal maximum is negative 14.87 degrees. That's the angle where if we will rotate, we'll get the maximum normal stresses, right? So I'm just going to draw the maximum normal stresses. This we can use this angle in transformation equations, or we can just directly use the maximum stress equations and the maximum principal stresses equation, and we can get the final answers. The answers what we got from last time was our maximum stress x prime, or you can also call it stress 1. It was, I think, 26.6 psi. And our stress y prime, which is also stress 2, we got was 176.6 psi. And our tau xy we got was 0 psi. So these are the maximum normal stresses you're gonna get ever in this particular case. And the angle which is gonna make is minus 14.87. So I'm just gonna draw which we got last time. So if we rotate the stress element like this, it was 14.87 degrees. So the maximum stresses which we got was, I think this was negative, right? So these are the stress 1, which is 26.6 psi, and this was a compressive force, which is stress 2, which is 176 psi, and we had no shear stresses. We also calculated the maximum shear stresses. So the angle for the maximum shear stress which we got last time was 30 degrees. So if we rotate this stress element at a 30-degree angle, we're going to get the maximum shear stresses. And we'll also get some normal stresses. So that angle was 30. So I'm going to rotate this stress element. And I can also write down the values. So our stress x prime, we can also use transformation equations, or we can, in this case, we have to use transformation equations for the normal stresses. So normal stresses we got were minus 75 psi, and stress y we got was negative 75 psi, and tau xy prime from transformation equations, or we also have an equation to calculate directly the maximum stresses, and this is from here we got 201, I think negative, but we have to like confirm. So I'm going to draw this stress element here. So it's a 30-degree, and we're going to get the maximum shear stresses as 201 psi. But we'll also have some normal stresses in this case. And this normal stress would be equal to 75 psi, and this normal stress would be equal to 75 psi. So this is what we did last time. So we can see if you calculate the maximum principal stresses, you're going to get shear stress 0. So in case of maximum principal stresses, you'll always get shear stress 0, but you'll have maximum. So maximum you can get is 176. You cannot get more than 176 of normal stress. And if you try to figure out where you'll get the maximum shear stresses, that's the angle. So if you rotate this stress element at a 30-degree angle, you're going to get the maximum shear stress, which is 201 psi. So you're not going to get more than 201 psi no matter how you rotate the stress element. The maximum you're going to get is at 30 degree. But at 30 degree, you'll realize you'll have normal stresses, little bit of normal stresses, but they're going to be equal. And we can calculate all this using transformation equations and the maximum stress equations. Now we'll try to use Mohr circle, and we'll try to draw all those stresses on a Mohr circle. So in Mohr circle, it says the first step is draw coordinate axis. And we have to draw coordinate axis for normal and shear stresses. And we have to make sure that we have positive normal stresses on x-axis pointing to the right and positive shear stresses pointing to the downward. So what it means is that we have to draw a x-axis and y-axis. So we have already had this x-axis and y-axis. You have positive to the right and positive to the downward. So that's how it is. That's the convention. So our positive normal stresses are going to be towards the right, and the positive shear stresses are going to be downward. So our first step is draw coordinate axis. So we have drawn this coordinate axis here. Our second step would be, and in this case, I can positive stress is right side and positive shear is downside. I mean, that's just a convention. So, but when we'll draw, then it will become even clearer. But x-axis is the stresses, normal stresses are positive on the right side, and shear stresses are positive downside. So our second step is calculate center. So we have to calculate center point of a circle. So where is the center being located? And then we also need to calculate radius, and then we can draw a circle. So we have to calculate center, and the formula to calculate center is stress, average, and zero. So basically you have to calculate average stress. So average stress this is average of normal stress. So let's calculate average of normal stress here. So we have to, second step is we have to calculate center, and center, the formula is This is the formula to calculate the center of a circle, which is stress average and zero. So what is stress average? Stress average is basically stress x plus stress y by 2. And our stress x is 100. And our stress y is negative 250 by 2. So if you calculate, you're going to get negative 75 psi. So our center point is negative 75, 0. That's our center point. So we have a center point which is negative 75 and 0. So I'm gonna just plot this on this Mohr circle, the coordinate axis. So let's just say each box is uh, 20 psi, just for reference, right? So if this is 20, so 20, 30, 40, 50, 60, 70, so it's gonna be somewhat here, right? 20, 30, 40, 50, 60, 70, 80, so it's gonna be somewhere. So this is our center point, which is negative 75 and 0. So we have the center point now. All we have to calculate is radius. So once we can calculate radius, we can draw the circle. And I'm gonna write down the formula for radius. So the formula for radius is stress x. I can write the formula for radius down. Calculate center and calculate radius. So I'm gonna write the formula for radius here. So for radius, the formula is stress x minus stress y by 2 whole square plus tau xy whole square. So that's the formula for the radius of a circle. In this case, in case of our transformation equations. And if you try to solve for this, our stress x is 100 minus our stress y is negative 250 divided by 2 whole square plus our shear stress is negative 100 whole square. So if you solve this, you're gonna get 201 psi. Uh, we'll it's gonna be the same as maximum shear stress. Yes, yes, always, all for every stress element. Yes, and we're gonna see this when we're gonna draw this here. Let's go. I guess that's the formula for maximum is different or is the same. Yeah, so the formula for maximum shear stress is exactly as radius. So now we have 201 psi. So that's the radius from the center. So I'm gonna just go 200 points here, 200 here, 200 here, 200 here, and then I can just uh, draw the circle. So it's gonna be 20, 30, 40, 50, 60, 100, 20, 30, 40, 50, 60, 100. I think it's this should be this point. should be this point. So now we can just draw the circle. Let's try it. So now we have a circle, and these are the stresses basically. This is normal stress, and this is shear stresses. So we can see that's the maximum amount of shear stress we are getting, that point. This is the maximum amount of shear stress we're getting. That's the maximum normal stress, and this is also a maximum normal stress. So all we have to do is calculate the center using this formula and calculate the radius using the formula, which is basically the same formula to calculate the maximum shear stress. So once we have the Mohr circle, then we can calculate anything we want to calculate, or we can just figure out. So this distance is the radius, right? And this distance is basically 201 psi. Or I can just write it somewhere else. This is the same as this distance. So this is radius, which is 201 psi. So the third step was draw a circle, which we did. And the fourth step is basically we have drawn the Mohr circle, but now we can extract. But what we can do is we can try to draw these stress element on a Mohr circle. So basically we can, all these points anywhere are basically stress elements rotated at a different angle. So this is a stress element. We can just try to plot this stress element over here. So the way we will plot this is this way. So whenever we have to plot a stress element on a Mohr circle, we're going to use x-axis and y-axis as like this. Stress x and tau xy is going to be 1 point, and stress y and negative tau xy is going to be another point. So we can transform the stress element into these two coordinates or points, and we can plot them over onto the circle. So in our case, stress x is 100 psi, right? Stress y is negative 250 psi. And tau xy is also negative 100 psi. So we can convert them into points to be plotted on a circle. So our stress x is 100 and our tau xy is negative 100. Oops. Okay. tau xy is negative 100. And our sigma y is negative 250, and our tau xy is negative, so it should be 100. So if you try to plot this, it should come out to be on the circle. So you can try to plot this 100, negative 100, and minus 250 and 100 on the circle. So this is 0, 0, right? This point is 0, 0. So this point is 0, 0. So can you guys try to plot this point? This point is 100, 100. So you have to go 100 here and 100 here. Because 100 negative, yeah, so negative you have to go upward, positive you have to go downward. So that was the convention we started with. So you go 100 here and 100 here, you're gonna get some point. So I'm gonna go 100 here, 20, 30, 40, 50, 60, 70, 90, 20, 30, 40, 50, 60, 70, 80, 90, 100. This is 100. And 20, 30, 40, 50, 60, 70, 80, and 90. So this is our point. This point is 100 and negative 100. We can also plot this point. We can also plot this point. It's going to be negative 250. So we have to go negative 250, and then we have to go 100, which is going to be down. So 20, 30, 40, 50, 60, 70, 80, 90, 100. 20, 30, 40, 50, 60, 70, 80, 90, 100, 200, 220, 30, 40, 250. This is 250. And 20, 30, 40, 50, 60, 70, 80, 90. So it's going to be roughly this point. So this point is basically negative 250 and 100. So we can draw a straight line if we want to. This is, so basically this is our stress element. So stress element is plotted over here. So this was the stress element which was given. And can you calculate the maximum shear stresses and the maximum normal stresses? This point will give us, or this point, any point, this point is the, so here you will get the maximum shear stresses, right? Here you'll get the maximum normal stresses. So the maximum shear stress is, I guess that's the maximum point of negative shear, positive shear you will get, and that's the maximum point where you'll get the negative shear. So can you guys tell me what is this point? But you guys can all understand, right? This is the maximum value of the shear, and this is also the maximum value shear, because this is, this you'll get the maximum value of shear. Here also you'll get the maximum value of shear. It makes sense? And here you'll get the maximum normal stress, and here you'll get the maximum. This is also like negative, but maximum. So if you can, from the Mohr circle, if you can give me these values, then we can compare it with what we calculated from the equations. You can just directly calculate from here 20, 30, 40, 50, 60, 70, 80, 90, 100, and 120. It should be something like 120, right? We can also calculate this value 20, 30, 40, 50, 60, 70, 80, 90, 100, 20, 30, 40, 50, 60, 70, 80, 200, 20, 30, 40, 50, 60, 270, something like negative 270. So if you want to calculate this point, I'm going to just write down this point. So this point is basically 20, 30, 40, 50, 60, 70, 80, 90, 100, 120. So I'm getting roughly 120, let's just say 120, and y-axis 0. And this is the point where I'm getting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 100, 20, 30, 40, 50, 60, 70. I'm getting 270, which is negative, and y is 0. And here, this point I'm getting, it's radius, like the x-axis is, this is radius, so it's gonna be 200. 1, but I'm gonna write 200. And you also have this distance. Oops, sorry. Our x-axis, is 20, 30, 40, 50, 60, 70. X-axis is 70 and negative, and our y-axis is radius, right? It's going to be negative 200. And this point is also x-axis is negative 70, y-axis is positive 200. All these points make sense? Good. So we can compare with what stresses we were getting. So did we get the maximum? So we can extract also. So this stress 1 is 120 from the Mohr circle, PSI. And this is stress 2 is negative 270 PSI. Maximum shear stress is, let's just say, this value. T max is 200 PSI. We can also compare it with our values. But everyone is clear how I calculated this 120 PSI, how I got this negative 270, and how I get the maximum. We can also compare it with the results we got from the last time. So last time, if we want to calculate the maximum normal stresses, these are the values of maximum normal stresses we were getting. Is this the maximum? So you guys can check. I think I'm getting the same values. This, I don't know what I plot here, but. So the maximum shear stress was 201, which we are getting. And at that point, we had 75, 75, which is we're getting 70, 70 roughly. So you guys can also verify these values. This I got wrong, so I'm going to just delete this one. Also, we can calculate the angle, right? So let's try to calculate the angle. So we have this, and this is the maximum normal stresses, right? This is the maximum normal stress. So this angle should give us the maximum normal stresses. 2 theta s. Right? So everyone got this 2 theta p? So I can calculate for you guys. So I can just extract this triangle here. I'm gonna write this triangle here. This is 2 theta p, right? And this distance is 201, which is radius. This distance is 100. We can also calculate this distance from a Mohr circle, or you can also use, I think it's the formula for hypotenuse, a square plus b square is equal to h square, something like that. You can also calculate using this. You're gonna get 175. You can either use any angle, but I'm gonna use tan. So if you use tan, 2 theta p is gonna be perpendicular over base. Base is 175. So if you solve this, you're gonna get theta p as uh, tan inverse 100 over 175, and 1 divided by 2, you're gonna get 14.87 degrees. Similarly, if you calculate theta s, you're gonna get 30 degrees.